Okay, today we're going to continue talking about functions, going into lesson 2.2, the graph of a function. So in our previous lesson, we talked about how we can figure out if something's a function using the equation, also looking at a set of points. So now we're going to talk about the graph and how we can determine if something is a function looking at its graph. Okay, so learning targets today are identifying the graph of a function, and also being able to obtain information from the function, about the function from the graph. Okay, so go ahead and pause the video really quickly and just jot down those two learning targets if you haven't done so already. All right, so we're going to start by talking about the vertical line test, which I'm sure some or all of you have heard before. So just as a refresher, a set of points in the xy plane is the graph of a function if and only if a vertical line intersects the graph in at most one point. So remember we had said that the definition of a function means for every input, there is only one output. So anytime you input something into a function, you should only have one output as a result. Okay, so the same thing goes for the graph. So I'm going to give you a series of graphs here, and we're going to determine if they are a graph of a function or not. So remember, our inputs are always our x values. So I should be able to pick any x value along the x-axis, anywhere from -infinity to infinity. And if I were to draw a vertical line from that x value, it should only hit the graph once, because that would mean I would only have one y value that corresponds to that x value. So for example, okay, if I just drew a few vertical lines here, you can see that these vertical lines from the x value, so in this particular x value, the corresponding y value is right here. There's only one of them. Okay, so I should be able to draw a vertical line anywhere on the graph, and it only hits the graph one time. Okay, so for every input, there's only one output. So go ahead and determine if the other three are vertical line tests, or if the other three are functions using the vertical line test. Okay, for the second one, if you were to draw vertical lines through that entire graph, you can see that each vertical line is going to hit the graph in two places. Okay. So for this one particular x input, there are two outputs. So this would not be a function. Okay. For the third graph, draw a vertical line, and each of these x values only has one output, and it only hits the graph one time. So anywhere I would draw a vertical line on this graph, it would only hit the graph once, so that would be a function. And lastly, draw some vertical lines here, and all of these vertical lines hit the graph in two places, so this would not be a function. So it's all going back to that original definition. For each input, you have to only have one output in order for it to be a function. All right, so now that we can determine if a graph is a function or not, let's try to figure out some information about a graph or about the function. Okay, so find the following information about the function. F of x is equal to x squared plus 2 divided by x plus 4. So given this equation, I want to figure out some information about the graph, okay, about the graph of this function. And remember, we know that this equation represents a function. We know this represents a function because it has the function notation. Okay, so we don't have to figure that out. It gives us function notation, so we know we're dealing with a function. Okay, so we want to figure out, is the point -1, 1 on the graph? And what about the point 1, 3? So if the point -1, 1 would be on the graph, Okay, now remember, this is our x value, this is our y value. It needs to satisfy the equation. So if I were to plug in -1 for x and 1 for y, I should get that and equal the two sides to be equal. Okay, if both of those points plugged in together satisfy the equation, make it true, then that means that point is on the graph. Okay, so remember, f of x is just another way of writing y. So this could also be written as y is equal to x squared plus 2 over x plus 4. Okay, so I plug in my -1 for, we plug in our +1 for y and our -1 for x. I get 1 equals 1 plus 2 over -1 plus 4. So 1 equals 3 over 3, which is true. So since the point -1, 1 makes this equation true, then we can say yes, the point -1, 1 is on the graph. I'm going to go ahead and pause the video and do the same thing for the point 1, 3 to see if that would be on the graph. So when you plug in 1, 3, 1 for your x and 3 for your y, you should get the answer no. Okay, 1, 3 is not on the graph of this function. Okay. So what if I were to tell you that x is equal to 3? What is f of x? And then in that point, that's something that we have talked about already, but from there I want you to tell me, okay, what would be the point on the graph of f then, once I figured that out? Okay, so remember, x, okay, that's our input. So really what we're finding is f of 3. Okay, we want to figure out if we have an input of 3 for our x value, what is our output going to be? So 3 squared plus 2 over 3 plus 4. 9 plus 2 over 3 plus 4. We get 11 over 7, which means when I input 3 as my x value, I got an output of 11/7 as my y value. So the point on the graph would be 3, 11 over 7, as those correspond. Keep on going with this function. We're continuing to find some information about the graph using the equation. So now I'm told that f of x is equal to 1/2. So what would x be? So now I'm trying to figure out what input I would need to put in here. Okay, what would my input be to get an output of 1/2? Okay, so now I'm solving, instead of solving for my output, instead of solving for y, I'm solving for my input, which is x. Okay, so f of x is equal to 1/2. So my output is 1/2. That gets plugged in for f of x, okay, since that's what f of x is equal to. Then I need to solve for the x value. What x value do I have to input to get 1/2? Let's go ahead and solve this. We need to get rid of that denominator to solve it. So multiply this side by x plus 4. Multiply this side times x plus 4. Okay, and I get, oh, sorry, I guess we could, here, let's scratch that really quick. We also have 2 in our other denominator. Okay, so what we could do to make sure both of our denominators cancel out is multiply times 2 and by x plus 4. Okay, so that 2 will cancel out the denominator on the left, and the x plus 4 will cancel out the denominator on the right. So everything in my function is going to be multiplied by 2x plus 4. So 1/2 gets multiplied by 2x plus 4. And x squared plus 2 over x plus 4 will also get multiplied by 2x plus 4. So we can cancel out these denominators. And we get x plus 4 is equal to 2x squared plus 4. So this is now we're left with a quadratic. So since we have a quadratic that we are trying to solve, I want to get everything over on the same side. So it's equal to 0. So subtract x and subtract 4 from both sides. And I get 0 equals 2x squared minus x. Okay. Okay, the way we can solve a quadratic, we first want to check if it's factorable. So here I can take out a greatest common factor of x. I'm left with 2x minus 1. Using the zero product property, since I have two things being multiplied together and they equal 0, that means each of them could equal 0. So we get x equals 0 and x equals 1/2. So when I have an output of 1/2, then I have an input of either 0 or an input of 1/2. Okay. So the second question asks us, okay, so once I figure out what those inputs are, what are the points on the graph? So my x value of 0 was my input. I had an output of 1/2. Okay. When I had that input of 1/2, that x value, my output is also 1/2. Okay. So remember, a function, you can have, every input can only have one output. So if the x's are, if I have two x's have the same output, that's okay. Okay, we just can't have one input that has the same, or has two different outputs. Okay, so since this output of 0 right here, if I plugged in 0 to this equation, the only answer I would get is 1/2. If I plugged in 1/2 into the equation, the only answer I would get is 1/2. So this would still be considered a function. Okay, what is the domain of f? And we talked about this. This is just a repeat from the last lesson. So really quickly, we have a fraction as our function. So the denominator cannot be equal to 0 because we cannot divide by 0. So we know x cannot equal -4, which means the domain can be everything else but -4. So anything from -infinity to -4, and then from -4 to infinity is our domain. Okay, so let's try finding the x-intercepts and y-intercepts. So we're still continuing with our equation, trying to figure out information about the graph using our equation. So, same equation, f of x is equal to x squared plus 2 over x plus 4. Finding the x-intercepts and the y-intercepts. Now remember, if we have an x-intercept, okay, then any x-intercept, every point on the x-axis, the y is always going to be 0. So we're going to plug in 0 for y. Okay. Now remember, f of x is just another way of writing y. It's just telling us that that's our function. Okay, but it's still y equals x squared plus 2 over x plus 4. So I plug in 0 for the y value equals x squared plus 2 over x plus 4. Solving for x, so we have a fraction here, so everything can be multiplied by x plus 4 to cancel out that denominator. So I had to multiply 0 times x plus 4, and I had to multiply the entire right side by x plus 4. Okay, so these cancel out. 0 times x plus 4 is still 0. I get x squared plus 2. Subtract 2 from both sides and take the square root. So as you can see, we're taking the square root of a negative. Since we're trying to find information about the graph, there is no such thing as a square root of a negative, okay, or an imaginary number on our xy coordinate. So we can say there are no x-intercepts, okay, since we can't take the square root of a negative. Finding a y-intercept. Now we're going to plug in x for 0. So any point on the y-axis, x is always going to be 0. So we have y equals 0 squared plus 2 over 0 plus 4. Just plugging in 0 for x. Y equals 2 over 4. So y equals 1/2. Since we're, again, talking about the points on a graph, we're going to write this as a point. Our x was 0, and our y was 1/2. Okay. For a function, you should only have one y-intercept, because for the input of 0, okay, there should only be one output of 1/2, because this is a function. All right, let's start taking a look at the actual graphs and see if we can figure out information about that. So given this graph, and this is a function, it passes the vertical line test, I want to figure out what f of -3 is. So again, remember that the number in here represents my input, my x value. What I would like to find is the output, or y value, that corresponds to an input of -3. So if I go to -3 on my graph, okay, so x value of -3, just go down until it reaches the graph. The corresponding y value is -5. Okay, so f of -3 is equal to -5. Input of -3, output of -5. So if I have an input of 0, I want to figure out what my output is. So starting at 0 as my x value, go up until it reaches the graph, okay, and I have an output of 6. Last one, if my input, f of 5, if my input was 5, so that means my x value is 5, go down until you hit the graph. My output is also going to be -5 for this one. So your input is always your x value, just trying to find the corresponding y value that goes with it for that particular function. Okay, let's talk about the domain. So we have talked about domain a lot last class and in the last lesson. However, that was just with equations. So what about if we're just looking at a graph? Remember, the domain is the set of all x values for that function. So right now we're looking at a graph, and so you can just see, based on this graph, where the possible x values are. So in this particular case, the graph starts here. Now notice there are no arrows at the end of this graph. So that means that the graph does not continue on forever. It just stops. So you can see that our graph starts here at -9 and continues all the way till you get to +9. Okay. There is a point at -9, so it can be equal to -9. There is also a point at 9, so it can be equal to that. So it goes from -9 to 9. It's going to be your domain. So it's easy on the graph because you're just looking at it. What are all the x values that are represented on the graph? So what about the range? Now the range is all the possible y values. So we're going to write it as R. The range is all the y values such that, okay, so looking at our graph, we try to find the lowest point on the graph, which is going to be right here at -8. And the highest point on the graph is here at 9. So the range, all the possible y values that you can see on this graph, go from -8 to 9. Okay. Since there is a point at -8 and there is a point at 9, that means it can be equal to -8 and equal to 9. So we use those brackets. Okay, list the intercepts of f. So that means both the x-intercepts and the y-intercept. Okay. So x-intercepts is anywhere that it can cross the x-axis. So I have it hitting the x-axis in 1, 2, 3, 4, 5 places. So -9, 0, -5, 0, -1, 0, 4, 0, and 9, 0. The y-intercepts is anywhere that it crosses the y-axis. And remember, if this is a function, it can only have one y-intercept, because for that x input of 0, I can only have one output. So it crosses the y-axis here at 6. So 0, 6 is my y-intercept. Same graph. How often does the line y = 1 intersect the graph? Now remember, y = 1. That's just going to be a straight horizontal line that crosses the y-axis at 1. So just straight across, and that line continues on forever in both directions. So just draw on the line, and then we count how many times the line intersects the graph. Looks like 4 places. Okay. So right now we're just practicing looking at graphs and analyzing graphs. In this case, at this point, these graphs don't really mean anything, okay, just kind of giving you a graph and we're analyzing it. In the future, what we're going to do is we're going to have graphs that actually represent a situation. So we're going to need these skills to kind of analyze them and figure out, solve some problems with them. Okay, so for right now, we're just kind of practicing the skills before we apply them. Okay, moving on with the same graph. For what values of x does f of x = 6? Okay. So again, this is the same thing that we did with the equation. This case, we're looking at the graph. So my input is x, and my output is y. So in this case, I'm given what my y value is, but I need to figure out what input I need to put in to get an output of 6. Okay, so I'm given the output, I'm given the y value. So go to your graph and find out where 6 is on the graph, and the x value that corresponds to that is 0. Okay, so x is equal to 0. Now this one's a little bit different because it says for what values of x is f of x greater than 0? Okay, so when is the function greater than 0? So all of my outputs, okay, what range of inputs do I need to have so that all of my outputs or my y values would be greater than 0? So here, this way, is all of my y values that are greater than 0. So you can see that the graph is greater than 0 in 2 different places, here and here. So what are the x values that correspond to that graph being greater than 0? Well, right here, this little bump of values greater than 0 go from -9 to negative 5. Okay, so the x values are negative 9 to negative 5. The x values are inputs that give me outputs greater than 0, and the second area are from negative 1 to 4. So we would say the values of x range from negative 9 to negative 5. Okay, but not equal to, because we only want it to be greater than 0, not greater than equal to 0. So I don't want to include the x-intercepts where it's equal to 0, only greater than. So from negative 9 to negative 5, but not equal to, and then from negative 1 to 4. Those are the range of numbers, x values, in which my outputs are greater than 0. All right, so that is it for analyzing the graphs for now. Okay, so please bring a calculator on Monday and Tuesday or Wednesday, whatever period you are. Okay, because we will be doing some calculator work on both of those days. Okay, so if you need to rent a calculator, please come try and see me before then, and I can help you rent a calculator out. Otherwise, some way you need to get your hands on your own individual calculator to use those days. I do not have any extras for people to use, so please make sure you get one. We will be doing a lot of calculator work in this unit, so you need to make sure you have one. There will be calculator questions on the test for this unit. Okay, so come talk to me if you need to get one. I will see you guys all on Monday. I hope you have or are having a great weekend.